Okay, good morning, everybody, and welcome to those people who are joining us today. Either you're joining us during live stream, or if you're joining us at the later time, uh, that's perfectly fine. I'll welcome you all. So today, what we're gonna do is we're gonna talk about lesson 3. So yesterday we finished lesson 1, and if you're wondering what's happening with lesson 2, did we forget about it? Did we skip it? Yeah, we're gonna skip it for now, and we're gonna come back to lesson 2 at a later date. So today what we're gonna do is we're gonna talk about exponential equation. So in the past few days, a couple of days, we've been talking about exponential function. So the function talks about graphs, um, and plotting points, finding the intercepts and all that. But today, what we're going to do is we're actually going to solve equations. So, but before we get into that, I want to let's take a look at the review of laws of exponents because it's been a while since we talked about this. You might have taken grade 10 pre-cal, and it doesn't matter where you took it, but when you took grade 10 pre-cal, we talked about laws of exponents, and these are the rules, okay? So the very first one is called a product rule. Product rule. And what's happening there is that they have to have the same base. So here, the base is x exponent a, so x to the a, and then the dot here indicates it's a multiplication, and then x to the exponent b. So what happens when we multiply powers with the same base? The exponents are added. And we have to remember this when we talk about logarithm later at the later date. You'll see that, well, why are they all of a sudden got added? So we multiply powers with the same base, we add the exponent. And then right beside this is the example. So example 2 cubed times 2 to the fourth. We can rewrite that as the sum of the exponents, sum of 3 and 4. So 2 to the 3 plus 4. We can simplify that further. It's 2 to the 7th. Now, this is the simplified exponential form. And then if you type that into the calculator, 2 to the 7th is equal to 128. Okay, so this is the standard form. The next thing that we learned before is the quotient rule. Quotient means we're dividing. So if we are dividing powers with the same base, so this is the base x to the exponent a divided by x to the b, what we do to the exponent is we subtract the exponents. So here's an example. 2 to the fifth divided by 2 cubed. We can rewrite that as 2 to the exponent 5 minus 3. And then, of course, we can clean that up a bit. So it becomes 2 to the exponent 2. And standard form, or the answer will be 4. Now, when we look at the power rule, so what's going to happen? X to the a to the b. In this case, we have to multiply the exponents. So you can see x to the a, that's a base and then the exponent, all of that is raised to the power b. So we just multiply exponent. And here's an example. 2 squared cubed. So it's equal to 2 to the exponent 2 times 3, which is equals to 2 to the 6th, and that's equal to 24. This one here is another way. Then we have a fraction here, x to the a divided by y to the b, all of that to the exponent c. So we can apply the power rule here, and then we apply the power rule down there as well. So x to the a times c, that's that one, divided by y to the b times c. And here's an example. So 4 squared divided by 2 cubed. You notice that they're not the same bases in here. So, and then squared. So we can say, hey, that's 2 squared is 4. Sorry, 4 squared, that's 4 to the 4th. And then 2 cubed squared, that's 2 to the 6th. And then evaluating this 4 to the 4th and divide by 2 to the 6th, that's equal to 4. Also, we talked about negative exponents. And what does negative exponents do? What's happening with the negative exponent is we can make the exponent positive by taking the reciprocal. So if this is x to the exponent negative a, that's the same thing as 1 over x to the a. So here's an example. 3 to the negative 2 is equals to 1 over 3 squared. So make this negative exponent, changing it to positive exponent. Oh, I think there's a mistake in here. So this one should be 1 over 3 squared. Let's fix that one. This one should be 1/9. 1/9. Okay, so because that's 1 and then divided by 3 squared is 9. 1/9. Okay. What about the exponent of 0? 0 exponent. We touched on this one a couple of days ago as well. X to the 0 is equals to 1. So anything to the exponent 0 will equal to 1. So 5 to the 0 is 1. Okay. And then finally, exponent to the 1. Okay, what's going to happen when something is raised to the power of 1? X to the power of 1 will be just x. So it's 5 to the 1 is just 5. So what we're going to do is we're just we're going to take a look at example number 1. And it says here, evaluate the following using a calculator. Now, before I get into this part in here, I want to kind of refresh our memory in terms of how to deal with the rational exponent. So just kind of refresh our memory right there. I'm just going to grab a piece of paper and write that in. Okay. So rational exponents. I talked about this a couple of days ago, but just to kind of refresh our memory. So rational exponents is, what if we have x to the power of 3 halves? So something base to the power of a rational exponent, a fractional exponent. So this can be written as, okay, so the 2, the denominator and the exponent, that would be the index of a radical. So 2 goes there. And then the base will be here. And then the numerator of the exponent will be what it's raised to. So the 2 goes here. The 3 is there. And then the same base right there. Okay. So if we have if we have 9 to the 1/2. Okay, well, what does that mean? If we put that onto our calculator, we're going to get a number, but then we're probably thinking, how did we get that number? It's because it's going to be the 2 will be the index of a radical here. So 2, the 9 will be the base radicand, and then the 1 will be just the 1 right there. So 9 to the 1/2 really means square root of 9, which is 3, right? So 9 to the 1/2 means square root of 9. Okay, now let's do one more. 16 to the 3/2. Okay, I like 3/2 because this is gonna just give us a really nice number. So this becomes the 2 square root of 16 cubed. So we could take 16 cubed, but that's going to be really, really big number. I don't want to deal with a big number. If I want to do this mental math, I can just go, okay, I can take the square root of 16 first. Okay, I can take the square root of 16 first, and that gives me a 4, and then 4 cubed. Okay, so it's going to be 4 times 4 is 16 times 4 is 64. Okay, so that's basically a kind of like a review of rational exponents. So when we take a look at this part, we're getting into this one. Evaluate the following using a calculator. So 30 in here, just so that we know what happened to the 1. And so square root of 36 is 6. Okay. Here's the other thing that we can take a look at, okay, without using the radicals. Here's an alternate way. Okay, so here's the other possibility. What's going to happen? 36 to the 1/2. Okay, I know 36 can be written as 6 squared. Okay, so the 36 could be 6 squared, and then to the 1/2. Now, what's going to happen in here? 6 squared times 1/2, that's the same thing as 2 times 1/2. So really what we're doing in here is using the laws of exponents that we just talked about right above. So 6 to the 2 times 1/2, that's going to give us 6. 2 times 1/2 is just 1. And then 6 to the 1 is 6. Okay, so as you can see, that could be thought about like this. Alternatively, using the exponent rules, we can get to the same answer. Okay, now let's take a look at this one. What is this equal to? Okay, so I'm just going to look at this as a law of exponent, and then so that we're just focusing in exponent laws instead of radicals. Okay, so what's going to happen in here is 16. Okay, well, what can we do with 16 to the negative 3/4? We can change the negative exponent to a positive exponent by taking the reciprocal. So this, okay, I'll do the reciprocal. That becomes 1 over 16 to the 3/4. Okay, so I've dealt with a negative exponent first, made it a positive exponent by taking the reciprocal. Take the reciprocal. Once we have that, we can say, oh, okay, 16 to the 3/4. Well, I can take 16 and write it as a base 2. So that becomes 1 over 2. 2 to the, what exponent will give me 16? So it's going to be 2 times 2 times 2 times 2. So 2 to the fourth, that's going to give me 16. Okay, so that becomes, the 16 will be 2 to the fourth times 3 fourths. Okay, and we're doing this without the calculator, by the way. So it becomes 1 over 2, and this is power to the power. So we're going to apply the power rule over here. We're going to apply the power rule. So 2 to the exponent 4 times 3 fourths. Okay. Um, we can simplify that one. 4 divided by 4 cancels each other out. So we're left with 1 over 2 to the power of 3. And 2 to the power of 3, okay, that's not bad now. It's going to be 1 over 2 cubed is 2 times 2 times 2, which is 8. Oops, 1/8. Okay, so all the way from the top, just to kind of refresh your memory in here, first, we changed everything to a positive exponent by taking the reciprocal, which we did that. Now, we figured out that the base 16 could be written as um, a power with the base 2, so 2 to the fourth. And then from here, we apply the power rule. So multiply the exponents, simplified it, and then lastly, evaluate at the bottom. Okay, now let's take a look at letter C. This one here, this is a quotient rule. We're going to apply the quotient rule. We have the same base 2, and we're going to be dividing it. Dividing 2 to the 5th divided by 2 to the 11th. That's the same thing as 2 to the exponent 5 minus 11. 5 minus 11, so that's going to give me 2 to the negative 6th. Okay. I ran into a negative exponent again, so what I'm going to do is I'm going to take the reciprocal to make it a positive exponent. So that becomes 1 over 2 to the 6th. Okay, just want to make sure that's the 2 is the base and 6 is the exponent. And then 2 to the 6 is just basically 2 times 2 times 2 times 2 times 2 times 2. 2 to the 6, that's going to be 1. Okay, so 1 would be that one. And 2 to the 6 would be 64. Okay. 2 times 2, 4, 8, 16, 32, 64. Yeah, so that's 1 over 64. Okay, so this one here is, as you can see, it's evaluating. That meaning um, the word evaluate means what is the value or worth of given expression. Okay, this is an expression. Okay, not an equation. So now what we're going to do is let's take a look at example number 2. Example number 2. This one here, we have quite a bit of examples, and we'll just, do them, explain them really, really well. Okay, I gotta change my pencil in here. Hold for a second. Okay, so I'll just, while I'm fixing my pencil in here, I'll just read the question. It says there, example number 2, an exponential equation is one where the variable is in the exponent. One method to solve exponential equation is to convert both sides of the equation in terms of the same base. Okay, so that's the key thing, and that's what we're gonna try to do, is to put everything as the same base. Once we have the same base, we can easily figure it out. Okay, so let's see here. 9 to the x equals 27. Okay, well, how can we change? You're probably thinking, how can we change this as the same base? Well, the 9 could be changed to 3 squared. So using the same base, we can use base 3. Okay, and you're probably thinking, okay, well, how do I know it's base 3? We just know that from our experience. Okay, so just to kind of, we go here, base 2. Okay, so if you take a look at all the base 2, I'll write it all down because you will uh, recognize it the more you see it. So base 2, so 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4, which is 16, 2 to the 5th, which is 32, 2 to the 6th would be 64. So, with this same base strategy, we can write it like this. And all of these numbers could be written as base 3. Well, what's base 3? I'll just go here. 3 to the 1 would be 3. That's pretty easy. 3 squared, that's going to be 9. 3 cubed, that would be 27. And then 3 to the 4th will be 81. And then you could keep going. And okay, so then these numbers in here, 3, 9, 27, 81, could be all written as a base 3. And then base 4, I'll just do base 4 for now here. So base 4 would be 4 to the 1. That one's super easy, but base 4 squared, that's going to be 16. 4 cubed, that's going to be 64. Okay, and then yeah, so that's how you would know what base it is, just by looking at some of these information. Okay, just become familiar with it. So 9 could be written as base 3. 27 could also be written as base 3. Okay, I'll just bring me back my paper in here. So 9 could be written as a base 3, so that's 3 squared. And then 27 could be written as 3 cubed. Okay, that's that. Let's do that on this page. So 9 would be, instead of 9, I'm going to put 3 squared to the power of x equals, instead of 27, I'm going to put 3 cubed. Notice that I put brackets in here because I want to emphasize that this 9 is 3 squared. Okay, well, I can simplify that. This is going to be a power rule. So that becomes 3 to the exponent 2 times x equals to 3 cubed. Okay, now that they have the same base, so they're saying it's 3 to this exponent is equal to 3 to the cube. Okay, so if the base are the same, then the exponents have to be equal as well. So if the base are the same, then that means the exponents are also equal. So just focusing on exponent. I'll just write it down here. If the base are equal, then the exponents must also be equal. Okay, so 2 times x will give us 3. So 2 times x equals to 3. Just focusing on the exponents. Solving for x, so divide by 2, cancel, cancel. So x is equals to 3 halves. Okay, so they're telling us that the exponent x, this x here, is equals to 3 halves. Okay, now let's take a look at example B. This is 3 to the exponent 2x, and then this is equals to 81. Okay, how can we make them the same base? Can I change this to a base 3? Can I change that to base 3, 81? And the answer is yes. 81 can be written as a base 3. That's 3 to the 4th. Just have that handy right beside me. So 3 to the exponent 2x is equals to 3 to the power of 4. Now that they have the same base, let's just focus on the exponent. Therefore, 2x is equals to 4. So divide by 2 on each side. So x is equals to 2. X is equals to 2. Okay, that one's pretty easy. Let's take a look at this one. Letter C. 32 and 16. Okay, is there a way that I can rewrite the 32 and 16 from this with the same base? Let's see. Oops. 32. Okay, I keep bringing this up because I want us to see this. 32 can be, and the 16 can be written with the same base of 2. So 16 is 2 to the 4th, and 32 can be written as 2 to the 5th. So 32, okay, this 32, I'm going to write it as 2 to the 5th, okay, and then to the exponent 3x minus 2 equals 2 to the 4th. Okay, now that they have the same base, so that means the exponents have to be equal. Therefore, 5 times 3x minus 2 has to equal to 4. Okay, so this one here is just one variable equation. So let's go ahead and do that. Distributive property of multiplication, that this becomes 15x. 5 times negative 2, that's going to be negative 10, equals 4. Bring this over there to the other side, then negative 10 goes to the other side, so 15x equals to 4 plus 10. So 15x equals to 14, and then divide by 15 on each side. So therefore, x is equals to, I'll just do it on the side here. So x is equals to 14 over 15. Okay, so that means that if I put 14 over 15 where the x is, and I try to figure this out, it's going to equal to 16. Okay, that's what it means. Now let's take a look at this one. Okay, this is base 5, and then this 625. Can we write that as a base 5? Let's see. I'll just go here, base 5. So base 5 is 5 to the 1, which is 5. That's easy. 5 squared is 25. And then 5 cubed is 125. And then I'll go 5 to the 4th. It's 625. Okay. So 100, yeah. So 625 can be written as base 5, 5 to the exponent 4. So this is going to be 5 to the exponent x plus 1. And then the 625, I'm going to write that as 5 to the 4th. And then I can't forget the squared because the squared is still there. Okay? And then it's going to be, let's clean this up. So 5 to the x plus 1 equals to 5 to the 8th. Okay? This one here, this is a power rule, right? We multiply the exponent. Now that the base are the same, therefore x plus 1 equals 8. The exponents are the same. Bring the 1 to the other side of the equation. So x is equals to 8 minus 1. So x is equals to 7. Okay, great. We're chugging along pretty quickly in here. If you have any questions, just make sure you um, send me a message and I'll be happy to explain something over again if you're not quite sure. Okay, now this one, letter E. Letter E is base 4, and then I got a 64 over here. Can we write down 64 as a base 4? So let me take a look at my thing. Yeah, so I can take 64 and write it using the base 4. That's going to be 4 cubed. So let's put that in. So 4 to the 6 times x is equals to 1 over, okay, what's 64 again? 4 cubed. 4 cubed. Okay, now this one here is 1 over 4 cubed. This 4, they look like they're in the same base, but they're actually not quite because the 4 is in the numerator here, and then the base 4 here is in the denominator. So technically, they're not quite the same yet. So what I'm going to do is I can see that it got reciprocated, meaning we can rewrite this as 4 to the negative 3. So 4 to the 6x equals to 4 to the negative 3. Okay, so remember when we said it's a negative exponent, it's the same thing as taking the reciprocal. We're going to go back. So now that we have the same exponent, sorry, same base, not exponent, same base, therefore the exponents have to be equal. That means 6x is equals to negative 3. Divide by 6, divided by 6, 6 cancel, so x is equals to negative 3 divided by 6. We can simplify that as negative 1 over 2, negative 1 half. Okay, great. So that one's not bad. It's nice because we were able to use the negative exponent there. Okay, let's take a look at letter F. 125 and 25. What could be the same base in here? 125 and 5. I'm actually thinking of two different ways of solving this, but I'm just gonna do one to make it a lot easier. Okay, what could be the same base for 125 and 5? So I'll take a look over here. I can see. Okay, 125, where is it? 125 is here, could be written as a base 5, and 25 could be written as a base 5 as well. So we're going to use same base 5. So this 125 can be written as 5 cubed. 5 cubed to the exponent of 2x minus 1. Okay, so that's this part there. And then the 25 can be written as 5 squared. And then the exponent x plus 4 still remains there. Now that they have both the base 5, if they're equal to each other, the same base, then that means the exponents have to be the same as well. So therefore, 3 times 2x minus 1. So I'm applying the power rule over here. I got to multiply the exponents, equals to 2 times x plus 4. So same thing, I'm using the law of exponent here, power rule. And this one is just a matter of simplifying. So distributive property of multiplications, 3 times 2x, that's 6x. 3 times negative 1, negative 3. 2 times x will give us 2x. And then 2 times 4 will give us positive 8. And then we got x's on each side of the equation. So let's bring the x's on one side. So 6x minus 2x equals to 8. And if I bring this minus 3 to the other side, it becomes plus 3. That becomes 4x equals to 11. And then divided by 4. Divided by 4 to solve for x. So x equals to 11 fourths. Okay. That one is not bad. That one is not bad. So the key thing here is recognizing how can I change these equation using the same base. Okay, there's going to be another strategy that we're going to take a look at later on, but when we take into the logarithm, but we're not going to do that right now. We're going to just work on the same base approach. So we did example number 2, A through F. Let's flip to the next page. um, Here. Letter G. We're doing very well today. Okay, so how do we do this one here? The 32 can be written as base 2, and then this one is kind of like a base 2, but it's in the denominator. So what we're going to do with this one here, because it's the 2 is in the denominator, we can write that as 2 to the negative 1. 2 to the negative 1. Okay, so applying the rule of negative exponents, 2 to the negative 1. So this 1/2 is 2 to the negative 1 to the exponent 2x minus 1. And then 32. 32 is the same thing as 2 to the 2, 4, 8, 16, 32. So that's going to be 2 to the 5th. Okay, 2 to the 5th. Okay. Now that we have the same base, we can say the exponents have to be the same, have to be equal. I'll just do it over here, just over there. Negative 1 times 2x minus 1 equals to 5. So we're just focusing on the exponents, equating them. So multiply in, that's going to be negative 2x. Negative 1 times negative 1 is going to be positive 1 equals to 5. Bring the 1 to the other side, so that's going to be negative 2x equals to 5 minus 1. And you know me, I like to show all of my work. So x is equals to negative 2. So some people are already thinking, skipping steps. Hey, that's perfectly fine. But I like to show off my work. It's probably easier for other people to see how I got the answer anyway. Okay, so that's not bad. We've got 3 more to go. We can do this. Letter H. This is a base 2, 64. So think about this. How can I change? Can I write 64 as a base 2? Can I write 64 as a base 2? Let me take a look. Yeah, so if you take a look at this one, 64 can be written as a base 2, 2 to the 6th. Should just have it right beside me. So this is 2 to the exponent 2x. Nothing to do there. But 64 can be written as 2 to the sixth x minus 1. Okay, same base, then the exponents have to be the same. I'll just go this way again. So 2x equals to 6 times x minus 1. So I'm using the power rule. As you can see, I use the power rule a lot in here, like different rules. So 2 times x is just 2x. Distributive property of multiplication, that's 6 times x, so 6x. 6 times negative 1 is negative 6. Okay, I got x's on both sides of the equation, so I got to put all the x's on one side. That's 2x minus 6x equals to negative 6. So 2x minus 6x, that's going to be negative 4x divided by negative 6. And then finally, I got to divide by negative 4, negative 4, negative 4 cancel. So x is equals to negative 6 divided by negative 4. You'll see that negative and negative will cancel each other out. And then 6 divided by 4 can be reduced to 3 halves. So this is x is equals to 3 halves. Wow, that's great. Okay, I hope you're still doing well. Let's take a look at the next one. 16 and 32. Now you're probably thinking I can write that as base 2. Base 2. Okay, so 16 can be written as, okay, so 16 can be written as 2 to the 4. Sixteen is 2 to the 4, and then the exponent 2x minus 3 stays there. And then 32 can be written as, okay, 32 can be written as base 2, 2 to the 5th. Okay, so that 32 is just written like that in a slightly different way, but then the x plus 3 exponent remains. Same base, the exponents will be the equal now, have to be equal. So let's put that over there. 4. I'll put a line right there just in case, you're going back to the notes and seeing, okay, which one is which. Okay, that becomes 4 times 2x minus 3 equals 5 times x plus 3. Okay, we're equating the exponents only. So multiply distributive property again. So 8x minus 12 equals to 5x plus 15. Put the x's on one side. So 8x minus 5x, 15 plus 12. So that becomes 3x equals to 27 divided by 3 divided by 3. So x is equals to 9. So it means that if I put 9 there and then 9 there, you're going to get the same amount. Okay, last but not the least, certainly. Okay, they've introduced the radical in here. So square root of 27 to the exponent x. Okay, What does the square root mean? That means there's a 2 in here and there's a 1 in there. So 27 can be written as 1 to the exponent 1/2. Okay, so this square root of 27 is the same thing as 27 to the 1/2. And then I'm not going to forget the x equals to 1 over 9. Okay, 1 over 9. Okay. What can I do? What would be the same base for these two? 27 can be written as a base 3. 27 could be base 3. So that becomes 3 cubed. Ooh, it's getting complicated in here. Oh, I don't like that. It's kind of slanted. I'm going to rewrite that again. It's the same thing. I'm just going to rewrite it. So 27 can be written as 3 cubed. But then I still have the 1/2 there. And I still have the x there. Equals to, now this one, it's going to be 1 over 9. Well, I can write that as 1 over 3 squared. Now, this ones are, we can see that they're both base 3, but this 3 is in the numerator, and then this 3 is in the denominator. So what we're going to do is we're going to put this in the numerator, and that will make it a -2 exponent. So this is, you can simplify all these stuff. So 3 times 1/2 times x. So that's going to be just 3 halves x. Okay. That's 3 to the 3 halves x is equals to 3 to the -2. Okay. Okay. Okay, just to kind of, I don't know, no one's asking question. How did we get to that one? That's a weird thing about having online, because I can't hear you. And you can't ask questions. How I got to that part, I got 3 times 1/2 times x. So I multiplied these two. 3 times 1/2 is 3 halves times x. So now we're here. Okay, same base. The base 3 are both in the numerator. So therefore, 3 halves, I'm just focusing on the exponent now, equals to -2. So solving for x, so cross multiply there, so that becomes 3x equals to -4, and then divided by 3. So x is equals to -4/3. Okay, great. So that's that. Well, that concludes our lesson. This one is actually not so bad of a topic. It's quite simple. Um, it's it's easy once we know and remember the laws of exponent. Okay, so the key thing is knowing your laws of exponents. Okay, review those things, and then asking yourselves, how can we make the same base using the laws of exponents? And then once you have the same base, you can just equate your exponent and solve for x. So yeah, it sounds like it's a not so bad of a topic. It's going to be an assignment time uh, for the rest of the time. or whenever you're doing this, because these are your assignment or practice. I highly encourage you to complete all those, showing all of your work. And if there is something in here that you're not sure of, please let me know. And next time we, you know, talk about this, I can um, I can actually go over some of these questions. Okay, so this one, assignment there. Okay, so I wish you great day of learning whenever, uh, whatever part of the day that is, morning, afternoon, or evening, or late at night. Um, and yeah, all the best to you. I just want to remind everybody that tomorrow is a Good Friday and there are no classes. I mean, no classes, no school going on tomorrow. So that would be a great time to for you to do some work if you are able to work on those questions and get caught up. Okay. Other than that, have a wonderful day and I will talk to you soon. Okay. Goodbye for now.